गेहूं गर्म पानी से नहा लेंगे खाना आएगा करते हैं। हमने बोलते हैं कि डालो 5 लीटर का
जिस दिन में ज्यादा हुआ है वही को खाएं जिस दिन में अन्नों बिना करेंगे अरे आ गया मेरे सब दे दो कपड़ा दे दो दोनों के साथ पानी खाने में अच्छा लगता है।
क्या पका रही हो यार?
अरे मैं सब्जी है जगवा रख ले जगवा है जगवा के लिए कोई ना दे जगवा के लिए क्या करता है बोल तू बोल
क्या करूं अब?
मेरे को क्या करता तू क्या करेगा तू सोचेगा ना बोल तू बोल कितना चाकू लेके मेरे को पता है ना
यार हो ना गेहूं के लिए
हाँ पानी भर दे वाला बोल तू वो खाने हेलो हेलो हाँ बोलिए मनीषा जी नहीं भिजवाए कल भिजवाए हाँ 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 ठीक है ठीक है ठीक है हाँ हाँ ठीक है
Last session, we started with the behavioral style of modeling. So, what is the difference between behavioral style of modeling comparing to other level of modeling? Behavioral level of modeling is nothing but a high level of modeling, where you are modeling with respect to what? Algorithmic manner. So, you'll be not using the primitives, correct? You are not using the what? Continuous assignment statement. So that behavior you are going to model in terms of algorithmic manner. This model of technique, we call it as a behavioral model style. This we call high level of modeling technique. So this is allowing designer is more flexible comparing to all other techniques. Correct. So this is a preferred one. This level of abstraction is preferred one because of more flexibility. Okay. So also we discussed about in the last session we started about this behavioral style. So behavioral style in Verilog supports what are the structured procedural statements? Always, and in Verilog there are two types of the procedural statements it is supporting. One is what? Initial block. This is the initial block. And second one is the always block. Always block. What is the difference between initial block and the always block? Can you compare or differentiate between the initial block and the always block? The initial block is executing one time in simulation, where always block is a continuous loop like a fashion. Whenever the event triggers, your always block is responsive, meaning that suppose if I'm writing always, I'm going to write the event. Event can be denoted by _. I'm a functional event, let us take A, B, R, C. I'm writing A, R, B, R, C. I'll be writing the statements inside this. So if there are multiple statements, what I should do? I should group it, begin and end. So how this always block works like it is a continuous loop like fashion. Whenever any event triggers here, triggering means A or B or C value changes, your always block is be responding to this. Where in case of initial block, correct, how this initial block works? It is doing only one time execution. Any change in A or B will not what? Monitors. Where do we need this kind of always block? Where do we need this kind of always block? So where there is a digital circuit, where my power will be switching on, until my power is switched on, I want a continuous repetitive activity, like clock generation for the traffic light controller. The clock generation should happen continuously until externally we will put a switch on. Correct? So these kind of continuous activities that can be done through what block? Always block. So initial block will be used in preferred or recommended to use in where test benches. This is not synthesizable. Okay. So what is the use of the initial block? What are the uses of the initial block? It is a use for initializing the variables, correct? Monitoring the variables, generating the waveforms. For this uses, so we'll be using the procedural statement that is nothing but an initial block. Let us quickly recap what we discussed in the last session regarding a procedural assignment statement. Also, we can call procedural statement or procedural assignment statement. We started with the behavioral style. So we know that there are two kinds of procedural blocks are supported in Verilog. One is what? Initial block. Another one is always block. Where this initial block execute at once at the beginning of a simulation. So where this always blocks work, how it works? It is a continuous loop that never terminates. Wherever your event triggers, always your always block will be responding to your triggered events. So it is used in where? Test benches. It cannot be used in where? Synthesis. That's why this is recommended to use in where? Test benches. The constructs which are using in the design file will be synthesizable. So that this is not recommended to use in the design. So it can be using for the test benches. Okay. So a procedural block defines means the region of the code containing the sequential state. If I am using two procedural assignment statements like what? Initial block and always block, those blocks contains what? Containing what? Constitutes a sequential statements. What is mean by sequential statements?
क्या हो गया?
So one by execution, one
हाँ?
by
क्या हो गया? अंदर क्या
So
खोल
that we call it sequential statements. Again, these sequential statements, which you are used in initial block and always blocks, can be classified into two classes. One is blocking statements and non-blocking statements. You can understand. So the statement execute in order the way which you are correct. This sequential statement inside the initial block and always block, which will be executed based upon what the specified simulation time we are given. Correct. Based upon that, it will be executed in the initial block and always block. So we talked about this initial block, right? How you can write the initial block? It is start with the initial keyword. There are multiple statements. Begin, group with the begin and end. So all the statement inside the initial statement constitutes a what block it is? Initial block. To keep remember that nesting of initial block inside the always is not allowed in the Verilog. Nested procedural statement is allowed. Whether you can write the always block inside the initial or initial inside the always. So because these are concurrent procedural statements, what is mean by concurrent means? These are started executing parallel execution. Time t0 concurrently it is executing. Termination is depending upon number of statements inside the procedural statements. Correct. So whatever the statements you are writing inside the initial statement, that constitute a what block it is? Initial block. Okay. So if there are multiple statements are there, we should group with what? Begin and end. Group inside a begin and end structure for the multiple statements. This statement start executing at what time? Time t is equal to 0. If there are multiple initial begins are there, all are start executing at what time? At t is equal to 0 time. Correct. So execute only what? This initial block. Only once in the simulation. Did you understand this? Because we are more using the initial block and always block. To understand how you can write the blocking statement and the non-blocking statement, these are very, very essential. Okay. So there are multiple initial blocks are there. All blocks are start executing out concurrently at the time t is equal to 0. You can agree this? If there are multiple what? Multiple initial blocks are there. So initial block is typically used to write the what? Test benches for the simulation. To specify the stimulus to apply the design under test, DUT, correct? And specify how the DUT outputs are displayed and handled. So we'll be using what? Initial begin. Specify the files where the waveform information will be dumped. We are not working on this. In some of other simulators, like if you are using EDA playground, we need to dump the file where the wave information to be done. Did you understand? Model sim and whatever the online compiler I'm using, there is no need of adding this file to check the waveform. When you are working on EDA playground compiler and some other compilers, we should need to dump this. So these are the use of what? Initial block. Initial block. So this is an example we saw. I think one example we saw that how that initial block will be executed. All are concurrently executed, correct? Now look at this is a test bench example. So here A, B, C are the inputs, sum and C out are the outputs. Now how many initial blocks are there in? There are 3 initial blocks on how these are executed. 3 initial blocks are executed concurrently. At the first block execute at what time? All these blocks will start executing at that time t is equal to 0. This is time t is equal to 0. This also start executing at what? Time t is equal to 0. The third blocks terminate simulation at what? I have specified the what? Time here. So this block will terminate and execute at time t is equal to 0. At the same time, C in assigning to what? 0. And second block also executing at time t is equal to 0. And A and B is assigning to at what time? At 5 time. Again, these are the sequential statements, right? Inside in this initial block and always block will be what? The structure will be like sequential statements. At what time next B is assigning to 0? At a time 10. This is 5, right? Then this will be executing at what? This is T5. This will be executing at what? T is equal to 10. and then finishing at what time? At t is equal to 25. This initial block will be terminated at what time? At t is equal to 25. So this is the way you can use the initial block in the test benches. Correct? Now you can also use the shortcuts to declaration of the variables. So the output and range can be declared together in the same statement. Correct? How you can declare? Suppose I am writing the output range 7 down to 0. Data is an output variable. This also can be declared like this. Instead of this, I can write what? Output 7 down to 0 of data, comma, range 7 down to 0 of data. This is a way, the shortcut way you can declaring the statements. So a variable can be initialized within the declared. Suppose I am writing range clock is equal to 0. So instead of this, how you can write? Range clock, or you can use what? Initial block. Initial block clock is equal to what? 0. So these slides will explain that the shortcut declaration of the range variable or output variable or how to initialize in the clock. Correct? This is a way you can initialize the clock.
अब क्या ना मेरा पेट
This is
मेरा
a way you can declare
कड़वा
shortcut way of declaring the variables. Correct. So this is the initial block. So now coming to what another procedural statement is nothing but what? Always block. What is this always block is? It is continuous loop like a function. All the behavioral statement inside always block statement constitutes what block it is? It is always block. It is a always block. The multiple statements also grouped in the always block using what? Begin and end. There are multiple statements are there. You can group it what? Begin and end. The always statement start at what time execution? At time t is equal to 0. Execute the statement inside the block repeatedly. Where in initial begin what happens? Only one time execution. So this execute the statement inside blocks repeatedly and never stops until it encounters with what? Some stop signal, dollar symbol stop, or a dollar symbol finish. Did you understand the always block? Okay. So used to model the block of what it is. What is the use of this always block? What is the use of the always block? Always blocks are used to model a what? The block of activity that is repeated indefinitely in the digital circuit. Like a clock generation in the traffic light controller, and we need to generate the clock continuously. It is generating the clock as long as this power is on. Correct. When power is off, then we are stopping. So until that clock has to be generated. So this is a repeated kind of activity I need in the digital circuit. So in such cases, you can use the always block. So this the model, the block of activity that is repeated indefinitely in the digital circuit. We need a what block? Always block. For example, clock signal that generates continuously is an example for what? Always block. So we can specify delays for the simulation. However, for the real circuit, the clock generation will be active as long as what? The power is supplied on. So this we can see simulation time. But basically that will be not synthesizable. When you converting your design file with the simulation time the way you want to bring the output at different simulation time. But when you convert this into the hardware, gate level, these delays will be not what? Synthesizable. Okay, so you can specify the delays in the always block. Correct? So we'll talk about more about the time controls and delays, the types of delays in the behavioral model style. We'll see. Okay, so however, in the real circuit, this always block is used for generation. Will be active as long as the power is on. I said the traffic light controller, one case where I need a clock continuous generation with the power is on. So in such case, I can use what? Always. So this is a few characteristics of the always block. Now let us see this example already we saw that. The model for what? Clock generation. So we are declaring the output range is equal to what? Clock. So we have initialized the clock with what? Initially 0 at time, what time it is? At time t is equal to 0. Here clock will be toggles, correct? toggles at what time? At 5 time. Since it is only one statement here, begin and it is not required. You can see this always clock also what? One statement I'm writing hash 5, clock is equal to what? Not of clock means it is toggling. So initially at the clock is equal to 0. Once it is coming to the time period of 5, clock becomes what here? Toggling. Toggling means it becomes 1. The next clock 5 time period toggles to 0, 1, 0, 1, so on. Like this is how it is time. Initially it is 0. At the time t is equal to 0. Once at time t is equal to 5, what happens? It toggles. Correct? It toggles again at time t is equal to 10, what happens? It toggles 0, 1, 0, 1 like this. Correct? So up to what time it will be doing? 0 to 5, 1. So I'm giving the finish time is 500. So this activity I need continuously I need to generate the clock. What I can use? Always. If I use initial, what happens? Only one time. Only one time. Now it is not going to generate a continuous clock. Correct. If I put this clock inside this always clock initialization, clock is equal to 1 tick, these are inside this always, what happens? Instead of this initial, if I'm using always here, what happens? There are two multiple blocks are there, two multiple always statements. This always statement, what happens here? Always my clock is 0. So I'm not getting this kind of response like it is toggling at the t is equal to 5, correct? So the initialization can be happening in the initial block. And if I want to generate the clock, I go with what? Always block. So initial and always blocks can coexist within the same Verilog model. So this is one example. Both this initial block and what? Always blocks are coexisted in this test bench, whatever the correct. So they all executed concurrently in this case. This is also executing at what time? T is equal to 0. This is also executing at what time? T is equal to 0. This is also executing at what time? At t is equal to 0. So end is depending upon the number of statements. So this initial, they all execute concurrently initial only once, but always what happens here? It is repeatedly, continuously, it will be repeating. Did you understand this? Initial and always block. Now let us see one more example. A module can contain any number of always blocks. Is it true? If I am writing a module, that module contains any number of what? Any number of always blocks. But all of them which are executed what? Concurrently. There are 5 always blocks are there. All blocks are executed what? Concurrently at time t is equal to 0. So this always block also having the event expression. Event can be denoted as @event. This part is required for both the combinational and sequential logic descriptions. Suppose I want to design a sequential circuit which changes only whenever the rising edge comes. So I need this trigger event. It should changes, my output changes, Q should changes only when the positive edge comes or only when the negative edge comes. Or if I'm talking about a combinational logic circuit multiplexer, output should change based upon the A, B, C or the select line. So that event expression is required for both the combinational and the sequential description. You can see in this case, in this always block, I'm not writing any event here. Correct? There is no event. I am generating the clock by specifying at what time period I should give T on and T off. Then I am writing the always block. But always block, when you come to the sequential and combinational, need an event. We need an event. Always at the event, either multiple sequential statements are there. This will be grouped with the what? Begin and end. So these are the statements. How this always block will work here? Whenever the event expression triggers means what? It changes. Always block is executing repeatedly. It is keep continuing. Whenever any event triggers here, my always block will be responding to the event. Did you understand this? This is an example of what? Event. Then what is the characteristics of the initial and always? What should be the left hand side of the variables and what should be the right hand side of the variables for the procedural set statements? Initial and always statements. In always statement, the left hand side should be always what? Rigid data type, or you can go with what? Integer data type, real data type, or real time data type. Most of the time when you are modeling the sequential circuit or combinational circuit also, the left hand side should be using what data type it should be. Register data type. It need not be a what data type. Net data type means wire data type. The initial block and the always. So why it should be always the rigid data type? So whenever event triggers, correct? At right hand side it is evaluating, that should be assigning to the left hand side. Until that, the left hand side should be preserve the what it was earlier triggering event. So to retain that information, we need a always at the left hand side of your initial block and always block. When you talk about always block, it should be what data type it should be? Rigid data type. So rigid data type is a discrete driven data type which is used to store the data. So if you see that assignment statement, continuous assignment statement, where left hand side should be, we are declaring characteristics of the left hand side should be what data type it should be? Net data type. That is continuous driven. There is no need of storing. Whenever right hand side changes, it is continuously assigning to the left hand side. The only rigid data type variable can be assigned within the what? Always. What is the for this thing? The sequential always block is only event expressed triggers. Means whenever the trigger triggers, then always block will be what? Executed only. It is like continuously looping like structure. Whenever the event expression triggers, then your always blocks will be responding to the trigger. Other time the block will be what? Doing nothing. It is continuous loop, but other time the block will be do nothing. And an object being assigned must be, therefore remember the last value assigned. Means the object assigned to must be therefore remember the last value which is assigned in the variable.
Hello.
Mean if I'm writing the let us write the model to this. I'm using always block. Always. I'm going to write the triggering event at the rate. Let us write the event passage of the clock. What is this event I'm writing here?
अच्छा तो एलर्जी का डॉक्टर बैठता है
What event I'm writing here?
बैठता ही है
Whenever the passage of the clock comes, you are asking to change the input, change the output.
अरे मुझे कुछ भी पता नहीं यार करवा के देख रहा हूँ
So what I'm going to do, I'm going to write like this. Whenever my positive edge
पता है यार
comes,
मैंने करवाया था
I'll be assigning Q is
तो एक
equal to,
दूध
let
से
me
निकला
write,
था और एक दस से निकला था
if
सोचा अब थोड़ा कमाल के लिए
let us write reset. If reset, what I need to do,
है
Q is equal to
अच्छा
0. Let us write Q is equal to 0. This means if reset is equal to 1, always assign Q to what? 0.
अच्छा
Assign Q to 0. Else means what? Reset should be 0. Now you can write Q is equal to D. Let me write the D flip-flop operation. What is the D flip-flop operation? Means output follows the input.
क्या वो पैथोलॉजी ले रहा हूँ
Correct. When reset is equal to 1, Q becomes what? 0. If reset is equal to 0, Q becomes what? T.
ऐसा है क्या
So output follows the
तो एक बार रेट
input.
पूछो ना कितना रेट
So here what happens? Whenever the rising edge comes like this is a rising edge. This is a clock
ये
effect,
जा
right?
रहा हूँ पक्का जा रहा
Whenever the rising edge comes,
हूँ
what happens here? My always block is responding to this triggering event. So this will be triggered at what? This event will be triggered at what? Whenever my rising edge comes. Whenever my rising edge comes, what I am doing? I am writing the condition that here, if my reset is equal to 1, do what? Q is equal to 0. If my reset is equal to 0, I am asking to do what? follow the Q follows the D. Until that, this is the definition of this. An object being assigned must be, therefore remember the last value. Means, once first raising gets the Q is equal to D, it should store the same information, retain the same information when it comes the one. Next raising edge. It should retain the value. Correct? The Q should be retain the value until what? Until it comes the next raising edge. To store that, I should declare this variable as one. LHS side should be what? Register data type. Did you understand? What is the reason? What is the logic? The basic reason that the sequential always block execute only when the event expression will be triggered. The other time the block will be doing nothing. So an object being assigned must be therefore remember the last value assigned, not continuously rewind. Means when right-hand side changes, it is not continuously assigned. It is a discrete given data type. When the event occurs, it will changes. Right-hand side evaluated, that will be assigning to the queue. It will store that. And whenever the next event comes, then for the next event, right-hand side will be performed, that will be assigned. Until that, to preserve that, when the next event occurs, to preserve that, the left-hand side should be declaring as a what data type? Crazy data type. Did you understand? If you declare that as a white data type, what happens? It will not going to retain. It is not going to retain. It is a continuously assignment statement. So always. So only rigid type type variable can be assigned within the what? Always block. So of course, any kind of variable may appear in the event expression, like a reg or etc. Always you should declare in the always block. The left hand side should be what data type it should be? Reg data type. It should retain the value. Did you understand this?
7-5.
Okay. That regarding initial block and the always block.
1-5.
Now inside this initial block and always block, what statement will be using? Sequential statement. So in Verilog, there are one or more sequential statement can be represented inside the initial block and the always block. What is the one or more way of representing the sequential statements in the initial block and always block is nothing but using blocking statement and non-blocking statement. The statements are executed sequentially inside the one initial block or always block. These are what statement? These are what? Sequential, procedural statement, initial block, always block, and procedural statement. Inside your initial block and always block should be what? Sequential statement. The way you are representing the sequential statement can be represented in two ways. One is blocking statement, another one is non-blocking statement. We'll see what is a blocking statement. Today we'll see some examples of the blocking statement and non-blocking statement. Correct? So where you can go into see the blocking and non-blocking statement? Where you can representing the blocking and non-blocking statements in the initial. That means procedural assignment statement. What are the procedural assignment statements are? Always block and initial block. If I'm talking about continuous assignment statement, whether I can represent the continuous assignment statement with the blocking and non-blocking. Continuous assignment statement is using what? Assign keyword. So this blocking and non-blocking will be represented to what? Procedural assignment statement. Those are initial block and the always block. So these statements are executed what? Sequentially. So these sequential statements are grouped. Correct? If there are what? Multiple sequential statement, multiple assignment statement inside what? Begin and end.
अरे मैंने पहले करवाया था इम्यूनोग्लोबिन का, तो डॉक्टर ने बोला था कि बाद में 2-3 महीने में अगर फर्क पड़े तो एक बार करा लेना वापस इतना होता है.
Correct? If the blocks are concurrent
मैं आपको इसी नंबर पर
statements, what we call is nothing but non-blocking statements. Did you understand this? The multiple assignment statement inside, what we are going to do? We are grouping with what? Begin and end. Block may be either what? Inside the begin and end, in your procedural assignment statement, if you write, the block may be what? Sequential execution. Execute sequentially, or this will be executed what? concurrently. Concurrently means what? Parallel execution. Depending upon the what? The type of the assignment you are writing. Depending upon the type of the assignment. So we are going to specify these are the blocks are blocking statement. These are the blocks are what? Non-blocking statement. What is the rule? Whether I can able to mix the both blocking and non-blocking. Today we will see regarding about blocking and non-blocking. What is the advantage of the non-blocking? How non-blocking will be used? Okay. Did you understand? What is meant by sequential statements? How you can represent the sequential statements? So this sequential statement in Verilog, one or more sequential statement can be represented inside the what? Initial block and always block. If there are multiple sequential statements are there, that will be grouped with what? Begin and end. Inside this, begin and end sequential statements can be executed what? Sequentially or concurrently, based upon the what? The type of assignment we are writing. That we call it procedural assignments. Procedural assignment statement means initial and always block. Procedural assignments means blocking assignment and non-blocking assignments. Did you understand this? So there are two types of assignment statements we have. One is what? Blocking statement. For the blocking statement, what operator will be using? Equal operator. The blocking statement is equal operator. A non-blocking operator is nothing but what? Less than or equal to operator. Less than or equal to operator. This is not a what operator. If you use this, the procedural assignment statement, that should be not a relational operator. That will be working as a what? Non-blocking operator. So the sequential statements we will be going to know. We will say that two types of the sequential statements are assignment blocking statement and non-blocking statement. So this is an example. So we are grouping the sequential statement using what? Begin and end. There are how many sequential statements are there? N number of sequential statements in this case. Correct. So a number of sequential statements when we group together using begin and end. If n is equal to 1, if there n is equal to 1 means what? Single statement. If there is a single statement, begin and end is not required. Now we spoke about how this initial block works, how this always blocks works. If you write the statement inside the initial and always block, what blocks these are? But sequential blocks and sequential statement can be represented in two forms. One is blocking and the non-blocking. Now let us start with what is meant by blocking and the non-blocking statement with the examples. So we call this is nothing but what? Procedural assignment. The procedural assignment statement can be used to update the variables of the types. The data types like you can use what? Reg data type, integer, real or a time, but not should be a net data type. The value assigned to the variable remains unchanged until the another procedural assignment statement assigns a new value to the variable. So this procedural assignment is totally different from the what? Continuous assignment statement using what keyword? Assign keyword. So that results in the expression on the left hand side, right hand side, continuously driven to the what? Netted end. In continuous assignment statement off to the left hand side, left variables. There are two types of procedural assignment statements here. One is what? Blocking statement and non-blocking statement. So where we'll be using blocking statement and non-blocking statement? Inside the initial and always means procedural assignment statements. So in the procedural assignment statements, the rule is that left hand side of the procedural assignment statement can be of what? It can be of reg, integer, real or a time data type, not a net data type. It may be a what? What is this? Nothing but sum of 15 means bit selection. Correct? What is this? Is nothing but IR of 31 down to 26 means what? This is a part selection. Or it may be a what? Concatenation of any above. Did you understand? So the right hand side expression can be constituted what? In the procedural assignment statement. It can be constituting of what? Net data type, registered data type, the type variable that evaluates to the value. It may be the bit selection, part selection, or a concatenation also, right hand side. So this procedural assignment statement can only appears within the what blocks? procedural blocks. What are the procedural blocks are? Initial and always. Initial and the always. So now let us begin with what is the blocking assignments. The blocking assignment can be denoted by what operator? Equal to operator. The general syntax of the blocking operator is the variable underscore name is left hand side is equal to what you can write at the right hand side. You can mention the delay. Delay or event. Event can be denoted as what? At the rate. Followed by what? Right hand side expression. So the equal operator used to specify the what? Blocking assignment. The blocking assignment statements are executing the order they are specified in the what block? Procedural blocks. Correct? What is the target of this blocking statement is? The target of assignment gets updated what? Before the next sequential statement in the procedural block will be executed. So this point is very important. What this point tells that? The target of assignment. What is the target of this procedural assignment is? It is getting updated before what? Going to the subsequent next statement. The next subsequent sequential statement, the procedural block will be executed. Suppose the example to this is nothing but if I am writing hash file, A is equal to hash file at B plus C, correct? And next is I am going to write D is equal to hash file plus again B plus C. How this will work in the blocking statement? I am using what operator here? This is my sequential statements. The sequential statements can be denoted in two ways. One is what? Blocking statement and non-blocking statement. How this blocking statement will be executed? At the time file, now B plus C plus will be added. That will be assigning to B. Now this is blocking this statement, right? That the next statement will be blocked here. This will be not executed. Now it is making what? Sequential execution. Then after 5, at the timestamp of 10, D is assigning to what? B places. This is the definition of this. This is my procedural assignment. Procedural assignments are two types. This is a blocking or non-blocking assignment. Blocking assignment. I am using equal operator. So this target of this assignment gets updated. What? What is the target of this is nothing but when this is executed. Before going to this will be executed. Assignment get be updated before the what? Next sequential statement in the procedural box will be executed. Did you understand this statement? So they do not block the execution of statement in the other procedural blocks. Means, what is the meaning of this second statement? What is the meaning of the second point? They do not block the execution of what? Statement in the other procedural blocks. Suppose you are writing a multiple procedural blocks. The procedural blocks you are writing using a blocking operator, equal operator. Multiple blocks are there. Whether it is going to block in the other procedural blocks? No, right? It is blocking at what? Inside that whatever initial you are using or always you are using. Correct? Means if there are two initials are there. This is a one initial. This is another one initial block. These are procedural blocks. Correct? In this procedural blocks I am writing this is A and D. Here also if I am going to write A and D, so this will be how it will be executed. So the first this will be executed. After this will be executed. But this is not blocking the execution of what? This initial begin. Because these two are started executing what? Concurrently. That is the meaning of the second point. They do not block the execution of the statement in other what? Procedural blocks. Inside that main procedural blocks only it is going to what? Block the statements. When you are using the blocking operator. Did you understand? If you are using two initial blocks, this will first this will be executed and then this will be executed, then it is sequentially it is going. This will be not blocking in the another procedural blocks. Understand? Second point. Is it clear this point? Can you tell me what is the first point it tells that in the blocking statement or a blocking assignment? What is this first point is? First, it is going to execute the one stage. Until get it is updating, it is not going to execute the second stage. Correct. So assignment gets updated before the next sequential statement procedural box will be executed. Correct. First A will be executed. This will be updated. Then it is going to what? Until that B will be blocked. Then B will be executed after assignment of this A. Correct. This is the first point. The second point is if there are multiple initial blocks are there. There are multiple initial or procedural blocks are there. They do not block the execution of the statements. Whatever sequential execution is happening in the each block, that do not block the one execution in the other procedural blocks. Did you understand this? So this blocking statement is basically recommended to model the what logic circuit. Combinational logic circuit. After seeing few examples, we will be realizing that why this blocking will be referring to what? Combinational, why can't be for the sequential. Recommending that the blocking modeling will be using to the one logic circuit is combinational logic circuit, not mostly preferred to the one sequential logic circuit. Did you understand? What operator we will be using for the blocking statement? Equal to operator. What is the blocking statement? What is a blocking statement? Blocking statement or a blocking assignment is one of the procedural assignment. Correct. The way it is executed is sequentially. So it is going to update the sequential block until it is going to what? Next block execution. If there are multiple procedural blocks are there, that will not blocks in the other procedural blocks. So this blocking statement will be recommended to use in the combination. With a few examples, you will be understanding this. Okay. Now see this example. Can you tell me what is the example of this? This blocking assignment can also generate the sequential circuit elements during the synthesis. Like example, multi-branching cases, we can use what blocking. In some cases, you can also use the what blocking assignment. But one case you can use the blocking assignments can be to generate in the sequential circuit the elements during the what synthesis. When you are doing the synthesis operation, like incomplete specification, the multi-wave branching you can done with the blocking assignments. Okay, like case statements, you can use the what assignments. Okay, most of the time it is used to prepare. Designer has to know that what blocking operator I used to solve the particular design. Okay, the recommending is that use the blocking statement for what? Combinational logic. So during the synthesis, to do this, for the multi-wave branching, you can prefer the blocking assignment. We'll see that example. Okay. So example for this blocking assignment, you can see we have declared the integer ABC, initial begin. So he is assigning here, what is the A values? What is the B values? What is C values? 15. Now what is the expression I am writing? A is equal to B plus C, B is equal to A plus 5, C is equal to what? A minus B. All this, how many initial blocks are there in? Only one initial block. At what time this is start executing? 0. At time t is equal to 0. How this will be executed? Look at this. This we call it as what? This is nothing but a sequential statement. The sequential statement, what block we are using? What assignment we are using? Blocking assignment. Equal operator. The way how this will be executed? First, A is equal to what? B is 10 plus, C is nothing but 15. Sorry, B is 20 plus 15 is 35. Correct. Then what happens here? Now A becomes what? 30. Sequentially it is executing, right? So it is blocking. When it is executing, this is blocking B. And also it is blocking what? C. So this will be executed, B will be executed when the preceding means before one A is executed. Correct? So now what is the value of B is nothing but? B is equal to A is nothing but what? 35 plus 5 means what? 40. Correct? Now C is executed before preceding statement will be executed. Correct? Now B becomes what? 40. Now I am doing what? A minus B. What is A value? Is nothing but 35. 35 minus 40 means how much it is? Minus 5. Did you understand this example how this blocking statement will be executed? The way you are specified the delays to your statements using blocking operator that will be executed. Now let us see this example. Now understand this example how this will be executed. What operator we are using? So initial begin. So this is a declaration of the variables. So reg x, y, z, and another one is reg 30 down to 0, 32 bit of AB. So integer sum. Then initial begin. So x, y, z will be x, y, z through sum will be sum. Even A, capital N, capital B is initialized at what time? At time t is equal to 0. Correct? All these variables will be what? Initialized. Now time t is equal to 5. What happens here? So A of 5 is equal to you are assigning what? 1 bit. And then next, at what time this is? At time t5, this is time. At time 15, we are doing the part selection. So x, z that will be assigning to this. Now this sum will at time 15 only. All this block will execute. First, this will be executed. Correct. So when this B is executed, means preceding statement has to be executed. After that, this will be executed. Then this sum will be executed at what time? After 15. Correct. At the time 15, sum will be doing what? Less 5. So this is another example how this blocking statement will be executed. Equal to operator will be executed. Did you understand? This is one example. Now let us go to the next example. If you simulate this one, blocking statement you are using. So model blocking teacher become D. Always at the rate, what is this is nothing but event, and we are writing representing what? Star. Star indicates what? Event variables like A, B, C, D. Now I repeat how many times? 4 times. Now what statements I am writing inside this always block is blocking statement. What is the blocking statement is? Equal to operand. At hash by what I am doing? A is equal to B plus C. At hash by D is equal to what? A minus 3. At hash by B is equal to what? D plus 10. At hash by C is equal to what? C plus 1. So for this we are writing the stimulus blocking. Stimulus block. So you write the module name, then declare the variables, initial begin, and monitoring this. Now we are assigning A is equal to 30, B is equal to 20, C is equal to 15, D is equal to 5. So I am repeating this for how many times? 4 times. Did you understand? Can you tell me, can you understand the output of this simulation of this example? At time t is equal to 0, all this will be assigned. Correct? At time t is equal to 0, A is 30, B is 20, C is 15 and D is 5. Now this statement will be expressed what time? At time is equal to 5. So A is equal to what? B plus C. So 20 plus 5 means 35. What is the B value? After this A is nothing but D. What is D is? A is now what? 35. 35 minus 3 means what? 32. Again, what is the? Think but now, right? B is equal to D plus 10. Correct? D is 32. 32 plus 10 means what? 42. Correct? Then what is the C value? Now this will be executed at what time? 15. 5. This will be executed at what time? 10. This will be executed at what time? 50. 20. At 20, what is C values? C is 15. 15 plus 1 means what? 16. Again, if I repeat this, what happens? Repeating how many times? I will repeat this for 4 times. At what time next I will be getting? At time t is equal to 25, what happens here? B plus C. What is B is 42. C is nothing but 16. So this is nothing but what? A is equal to 58. Now let us see this simulation out here. At A is equal to 0, correct? At A is equal to 0, sorry, T is equal to 0, A is 30, B is 20, C is 15, D is equal to 5. Same program. Correct? At T is equal to 5, what happens? A is assigning to 35. A is nothing but what? B plus C. At time T10, what happens? D is 32. At time 15, B is 42. Correct? These are executing at what time? 50. Correct? At 20, what happens? C becomes 16. Now I am repeating this for how many times? 4 times. What happens at the next 25? So this is B plus C. What is B is 42 plus C is nothing but 16. 42, 16 means what? 58. What is a D is nothing but in the next 30 time and time 30 D becomes what? What is D is nothing but A minus 3. A is 58 now. 58 minus 3 is nothing but what? Do you understand how you can see the simulation result of the blocking statements? So when it is executing one statement, it is blocking what? Another statement. It will start executing what? Sequentially. So this procedural assignment can be executed sequentially. Or what? Concurrent.
अरे नहीं हो रहा है, जाओ
Concurrently
ना,
means
नहीं
what
हो रहा
blocking
वो,
statement it is.
अब थोड़ा था गर्मी
Not
था,
blocking
खान लिया और
statement.
सब.
Concurrent, or you can call parallel execution. I hope this example is clear. Okay. Now let us see how non-blocking assignment can be used in the procedural statements like initial and always. The general syntax of this non-blocking statement is left-hand side variable. What operator I can use to this is nothing but less than or equal to operator. And you can what you can do? Specify the delay. Okay, delay can be specified in 2 ways. We'll see that in upcoming session. Intra delay and the regular delay. Regular delay and intra delay. Intra delay means before the expression you are going to write in the right hand side. That is nothing but intra delay. So regular delay is nothing but at the starting of your writing expression only if you want to represent, that is nothing but regular delay. There is a slight difference between regular delay and intra delay, which we see when you're dealing with the timing controls. Okay, so this is a general expression of the non-blocking statement. Left hand side variable name, correct? What operator this is nothing but